Hello everyone, my name is Sami. Thanks for joining us with another session in our user group. Welcome to Global AI APAC AI Community User Group. I'm super excited tonight. We have a great guest, Stefan Tempesta. He's going to talk about how to protect our financial ML workloads with confidential computing. I'm looking forward to this session. So I hope you guys enjoy the session as we do as well. Before we get to his session, there are some similar to usual. There's some housekeeping that we're going to go through. We have a LinkedIn groups as well as meetup groups, so feel free to follow us there and join our groups. There we'll post different content regarding to AIs and the events that is happening around our around the user groups. So feel free to follow us there and provide us feedback if you have any. If you're interested in public speaking, please submit your session. If you have a prototype you want to try out, or if you want to get into the public speaking, this is a good place to start. So submit your session through our GitHub page and we can take it from there. And in the end, we are part of Global AI Communities, and follow us there in Twitter, and also you can connect through our different channels that we have over there as well. Global AI Communities, they have different content, different sections. They're all AI related. You can surf and you can find other related and interesting areas that you might find good for your interest. Similar to previous time, here's Aradenja. We're going to go to news. JK is going to share with us some interesting news that he has tonight, and also then we're going to get to our regular session, and it will follow with the QA afterward. We started doing something new. We're going to play a game at the end, so if you have spare time, please stay back. We're going to play Among Us. JK is going to tell us how to play the game. It's quite fun. So if you have 10 or 15 minutes time, please stay back. And it's kind of fun. We're trying to make our sessions quite interactive. So we are trying to try different ideas. So if you have any ideas how we can make our session interactive, please share that with us. We are open to suggestion. We are thinking to improve. So we are iterating and we are growing as we go. All right. Stop me talking. I'm going to pass it on to JK to share with us his news. Thanks, JK. Come on up.
Hi, everyone. Welcome to APAC AI community. So I'm going to share you some interesting news that happened last month. So the first one will be the EU has considered banning surveillance AI. So basically that would be ban on facial recognition, ban on anything that would track your social credit score, like for instance, what we have in China or what's happening in Black Mirror. So in a way, they probably watched Black Mirror series and was like, yeah, I think we want to ban this. We want to prevent this. Okay, maybe that's fine, and ban this. So a very interesting things going on in Europe, and we'll see if that will start to happen in other countries as well. Now, the next news is a very interesting project by Google. You can go to wildlifeinsight.org if you're interested in how we are going with tracking all of the wildlife, their population, and how well we are at maintaining their population, and if they need help with that. So they're basically using vision AI to recognize different species and then try to count their population. Now, the next news is about Microsoft buying Nuance. Now, you might have heard about Siri, the Apple's voice assistant. Nuance is the company behind Siri, and they bought it for $19.7 billion. And it's actually one of the biggest acquisitions since LinkedIn, which was $16 billion. And the current plan is to use it in AI health, but we'll see whether they're going to extend that to, say, Cortana or enterprise. So next news is for AWS. They are now offering free digital training for business leaders that are interested in machine learning, AI, and similar things. So you can check out the URL down below if you're interested with AWS AI training. And the last news is something a friend of mine shared, and who was like, look, I want to really use this for other event sport because what this allows you is AI enhanced sport watching, and it actually tells you how it predicted something would happen. Like in this case, it tried to predict whether a person is going to catch the ball or not. It predicted it's going to be a disaster, but it actually did well. So this gives you like a insight how well an AI would work in real world, as well as trying to predict with the AI who is better at predicting what will happen in sport in real time. So I think experiences like this could really transform how we watch sports and other shows that are real time, and a lot of people like to predict a few seconds ahead what might happen, or even for the entire game. So it could be some fun addition. And with that, I'll go back to Somi. Hey, Somi, you're muted.
The most popular sentence in the year, I guess. Sorry. I was just saying it was interesting news. I really enjoyed. I like the one that is helping to help wildlife, especially in Australia. Last year we had a huge fire going on, and I guess having that will help us to save the remaining wildlife, which is good. So that was good. And interesting news with Microsoft was interesting as well. I'm keen to see how our AI is going to get empowered by these two major companies joining. So it will be very interesting to watch. So I guess we have to stay tuned for that. All right, thanks again for the news. So without any further delay, I'm gonna bring up Stefano, and we're gonna have his session. I'm interested to see his session. Hi, Stefano.
Hi, everybody. Thanks for having
How are
me.
you?
It's a great opportunity to be here and share this session with the community. Can you hear me well?
Thanks for joining us. Yes, I
Okay,
can.
beautiful.
How are you doing? Good. Thanks for fitting us in your busy schedule. I really appreciate your time.
No worries. It's always a pleasure. And, artificial intelligence is my passion. So happy to be here.
I know. Thank you. All right. I'm going to take off myself from the screen, and I'm going to give you the screen. So feel free to start your session whenever you're ready.
Okay. Yes. So thanks, everybody. Just a quick introduction. My name is Stefano Tempesta. I'm based in Melbourne, and I work at Microsoft, specifically in the Azure Confidential Computing product group. And I'll be touching today on a few aspects of confidential computing. But first, I want to start with AI, specifically machine learning, and specifically two use cases. So use cases in the financial space. So online payment fraud detection and credit risk prediction. Now, disclaimer, I'm not a data scientist. I'm an engineer or an architect, but I'm a man of technology, and I build application. But in this context, I'll try to walk you through some of the consideration in building applications or services using machine learning for these two financial use cases. And then we'll understand why confidential computing is important, not just for these two use cases, but specifically for those two, because they bring a lot of confidential data, and how this can be applied in the context of Azure. So Azure is our cloud of reference today. All right, so let's start with the first one, online payment fraud detection. Now, I want to invite you to look into this for a moment. Okay, so let me just prepare my screen for a second. Here we go. Have a look into this spreadsheet that contains a list of transactions. So the first column is a date, then a name of a person, a client. In this case, is always the same person, Mike Randall. Then we have a description of the transaction. Mike bought some petrol, parking, shopping, so on. Then we have a country where the transaction was executed and an amount, how much money the transaction was it. How many records do we have in here? Probably about 50. Can you spot something different, something unusual? And I'm sure you can, right? So if you just scan visually this list, you will easily identify that Mike bought some electronics in Kazakhstan for 2,000 euros. What's the anomaly here? It's not too much about Kazakhstan. It can be anywhere, it can be Italy, it can be Australia. It is the amount which is an anomaly. 2,000 euros, and he has never spent that amount of money before. There is something going on in there. Now have a look into this other one. Again, a list of dates, different clients, different people, but all shopping on Amazon. And again, most of the countries are in there. And there is again another anomaly. It's a little bit harder to spot. And again, don't get driven by the fact that is in Nigeria in there. That's the anomaly. The amount is insignificant. The problem is that in the same date, the 22nd of April, Johnny McTick bought 3 items on Amazon, but those transactions, 2 were in Ireland and 1 in Nigeria. Now, unless Johnny took a flight and flew from Dublin to Laos in Nigeria as soon as possible, as quick as possible, it's very unlikely that that happened. All right, now that was an easy game, 50 transaction or 100 transaction, and you could easily spot the anomaly in there. But Visa, the MasterCard, the credit card provider, handles 2,000 transactions per second. That is over 170 million transactions per day. Now, good luck doing the same things. Good luck opening 170 million transactions into an Excel spreadsheet. And now, obviously, it's not going to be an Excel spreadsheet for doing that, but you get the idea. We cannot identify anomalies just by looking at a list of transactions. This creates a significant problem, but can we even quantify how important is this? Well, a recent report from 2019 stated that the cost to the global economy for fraud is over $5 trillion. That's an incredible amount of money. So there is a problem in there, and we need to address this problem. Now, some good news, some bad news. There is banks or financial institutes, credit cards are typically very traditional in the way they manage this transaction. And the traditional approach to tackling this problem is to use some rules or logic statement. So they actually query this transaction and try to identify those that are suspicious. And they even do human review. So there are really people that actually go and look into that. Now, while there is some variation, it is notable that over 90% of online fraud detection platforms still use this method nowadays, year 2021. So banks, payment gateways, credit card providers, they're still very, very traditional. And while this is effective to some degree, in cases where there is a sufficient gap between an order being received and goods being shipped, it is also incredibly costly and far slower than something else that I would like to understand today. Now, the rules that are coded in this platform use a combination of data, horizon scanning, and even gut feeling. This is why most of you, including myself, probably have been driven to say, oh, Kazakhstan, oh, Nigeria, were a suspicious country. Don't get me wrong, nothing wrong in there. The problem is that these are based on some tables that are regularly maintained by people, by the security director or whatever the person is in charge of maintaining these sort of lookup tables. But take, for example, that there is a breach on credit cards in some countries, and this breach happens, say, overnight, and then you need to, someone has need to update these lookup tables, these tables with a blacklist of countries. It doesn't have to be necessarily geography, it can be some other factors. What happens is that there is a delay in maintaining this, and there is also a delay in restoring the normal execution, the normal lookup into this table that contains these rules. So this is happening, and we want to improve it. And this is where machine learning helps. Machine learning works on the basis of large historical data set, as we know, that have been created with a collection of data across multiple clients, multiple industries. And this brings also benefit not only to the larger banks, the larger credit cards, but even companies that only process a relatively small number of transactions are able to take a full advantage of the data set for their specific use case, for their own vertical. And this is because these data sets are actually available and shared. And we will see how we can share this in a very confidential way. This is where confidential computing enters in action. But let's go gradually. Let's have a look into this specific use case now. Now, the aggregation of data provides a very high accurate set of training data. And the access to this information obviously allows the different organizations, different businesses to choose the right model to optimize the level of prediction in their machine learning services. There are different ways of doing this. We'll focus on one technology, which is anomaly detection, and as the name implies, is looking for anomalies in a data set. Number of purchases over average amount per day, per week, per month. If there is an anomaly, there is an outsider out of the cluster that is typically identified, that is a potential fraud. It doesn't have to be is necessarily a fraud, but it could be. Now, how this works is with machine learning algorithm that look into they're looking to engineering some features, which basically means that they are constructing variables, values, these risk tables that I mentioned before, automatically. Maintaining automatically also by learning over time. So I mentioned that risk table that is maintained by country, but it can be by other conditions, by the security director in a bank. A machine learning algorithm is able to maintain a risk table automatically by analyzing the transactions that are processed. This is done in Azure, using Azure Machine Learning, using two algorithms or two services. One is called a PCA, which is a principal component analysis, and is a technique in machine learning that can be applied to feature selection and classification. So basically, the system explore the data set automatically without any pre-labeling of the data, and it tries to reveal the inner structure of the data and explain the variance in the data itself. So it's looking for the principal components of this anomaly detection. What are the components that drive these anomalies? And is as you can read on screen, is an unsupervised learning. So this data is not pre-labeled, so the algorithm itself try to find it by itself. Instead, if you already know the nature of your data set, you can try to work on label, so a supervised training, using another anomaly detection algorithm, which is called one class support vector machines. And we'll see this how it works in action. So this is Azure Machine Learning. You may or may not be familiar with it. You build basically a flow of execution of data, starting of processing your data, which starts from the data set itself, doing some transformation, and then training and scoring the model. At the end, Azure Machine Learning expose this algorithm, which is called an experiment, that you built as a service. So there is no infrastructure to provision for you, it is completely automated and exposes a REST API that you can consume in your application, even in an Excel spreadsheet. And then you can integrate with your payment gateway, you can integrate with your applications, and so on. So enough slides for now. Let me go and show you this in action. So I'm here in my Azure Machine Learning Studio, which is the environment for developing this sort of experiment. This is available at the URL that you see on screen in here. Let me zoom in a little bit. So it's studio.azureml.net. This is the classic client, which is not a client itself, but it runs in the browser. So there is no plugin, no desktop no desktop application to install, and you are ready to go. Then there is a newer client or studio environment that run inside the Azure portal. But I'll focus on the classic because it's the one that I use the most and I'm more familiar. I have different services that I have built. So let's look into the online payment fraud detection. Okay, so the way it works is really drag and drop. So on the left-hand side, you have a number of actions that you can perform. You have data set, you have transformation, you have input and output, you have the machine learning services itself. So these are snippets of code typically written in Python or in R programming language, but they are pre-compiled, ready for you to use. For example, we have anomaly detection, classification, clustering, and regression algorithm. And as said, for anomaly detection, you see we have the two algorithms that I mentioned before, the PCA, which is the unsupervised service for scanning all the data without knowing upfront the nature of the data itself. So it's looking for identifying the principal component in the anomaly. And the one class support vector machine, which instead looks for elements that are labeled or pre-labeled. And then obviously the other one, classification, regression, are different type of machine learning. We'll look into classification in the second case, in the credit risk prediction. So let's stay here for now. Now, these all visual, I said, drag and drop, but if you are a data scientist, a data engineer, and you can program in Python or in R, you can add a Python script or you can add a R script as well. And this is convenient to further personalize your machine learning flow. But I'm not going to do this today. As said, I'm not a data engineer, so I'm focusing on leveraging the capability of Azure machine learning as it is. So I'm starting from some payment data in here. So I'm going to look into the data set that I have uploaded before, and you can see there are some there is a timestamp in this format. There's client, the description, country, and the amount of money that was spent. So because the timestamp is this format that doesn't look like a date, I'm applying a SQL transformation. This SQL transformation is converting the time, which is expressed in a Unix epoch into a proper date. And then I'll do a little bit of selection of the columns that I want to use, because not all the columns may be relevant, and then split the data between those dataset or portion of the dataset used for the training and those other part that is used for the scoring. The portion of data used for training will go for anomaly detection. As you can see, this is a block that say, okay, do anomaly detection. And then I go in here and choose, okay, how I want to perform my anomaly detection, with the one class or with the PCA by algorithm. Now, because I know my data in this case, so let me show it this again. So I know that there is a timestamp, a client, country, and so on. So I know what this data is about. Then I can use the one class support vector. And then if I just look into this, no, sorry, not this, the scoring, obviously. If I look into the scoring, so which is basically the final output, you see that to the initial data set, this flow, this machine learning flow, has added a score probability, and this probability is an expression, a percentage, so 6%, 5%, 8%, that a value, that a combination of client, country, amount, and date. So you see now the date is expressed in a proper format that can be input with the year, month, and date. This combination may or may not be, so the likelihood, the score probability, that is a fraudulent transaction. So at the end, this is all done. I just had to publish this as a web service. So you see here on the bottom, I can just publish this as a web service, which I already done. So I move on the left hand side and I open my web service, which is this one. And then this web service has been published in Azure, completely hosted, serverless, with no infrastructure. Also, I mean, there is some infrastructure, obviously, but you're not configuring. It's the Machine Learning Studio that is taking care of it. So, the way it works is a REST API. There is an endpoint that is unique to you. You have to pass an API key, because again, this is your own web service, not a generic API. Is being deployed only for you. There is a unique ID for it. So then you have an API key that you have to pass in the request header, and then you pass a body as a payload that contains the client, country, amount, and date. And then you obtain as an output the score probability. A JSON object in input, JSON object in output. You can even do this in Excel, so you can download an Excel spreadsheet, and Excel has an add-on that connects directly to this very, very specific machine learning service, and then you can do all the magic directly into Excel, or just for testing, you can test in here. And you can say, Stefano, based in Australia, is going to spend $200 today, which is 22, right? I believe. Okay, and now this information is sent, and you can see it's been super quick. With this condition, based on the data that we have, there is an 8% probability that my transaction is fraudulent. Now, I guess that if I add the value, so I keep the same name, I keep the same country, but I increase the value, so 2000 instead of 200, and the same date, I would probably expect the, like, to go, oh, whoa, gosh, what happened here? To go a little bit up. So it scores 1, which is likely, and it went in a super higher value there, which is consider my data set is it doesn't have Australia as a country, so it's a little bit unbalanced towards other countries in some way. Okay, anyway, that was all of it. Let's move on in the interest of time, because I have so many other things to share. And if there are any questions, please feel free to type in the chat. We'll go into the Q&A at the end, because I don't see the chat in front of me right now. The second use case I want to show you is the credit risk prediction, similarly to what we have seen before, but a different type of a machine learning algorithm to use. The problem is identify a risk that when you apply, say, for a loan, so for a credit application, you are likely to repay in time. And I'm using an open source dataset. It's called the German credit data dataset that is available at this URL you see on screen. Happy to share it. This dataset contains thousands of transactions that have been anonymized. It contains over 20 variables for thousands of applications, and then is calculated as 700 applicants as low risk and 300 applicants as high risk. So this is the data set that we're going to use. I'm going to use a classification algorithm, which is a 2-class boosted decision tree. There are so many different types of classifications that can be done in Machine Learning Studio, but this one is a supervised method that predicts the likelihood that a person falls into a specific class. So the class is low risk or high risk, based on a decision tree. And the way a decision tree looks like, and I'll show you in the system directly, is like different bubbles that are decision point and nodes, branches. So assess the first bubble and say if it is more or less than this value. So for example, if it is in this age range, then is more or less likely that to be a good repair or not. And then it goes into the next decision. Okay, I assess age, then assess employment status, and then look into whether you own, you have other credits, whether you're married or not, and so on. And at the end, you want to evaluate the different models and see which one performs better. Okay, too many slides. Let's show this in the system. This one is slightly more complicated, but again, no coding at all. It's all done visually in Machine Learning Studio. So credit risk prediction, this one here. So we are starting from the German credit card dataset. And let me visualize this dataset for you in a moment. And as you can see, it contains different data in here, but it's column 1, column 2, column 3, column 4. So it's been anonymized. Now, the good news is that I'm able to get the name of the columns from the GitHub repos where this data sources is shared, and using the edit metadata action, which is a transformation action somewhere in here, I can add column names. And here we go. So now we have different columns names, which is incredibly convenient because then this allows me to do some pre-analysis, even visually. So for example, so you see you have duration in month, duration of the loan, the very likely that you have applied for. So now 6 months, 4 years, 1 year, and 2 years, and so on. And then there are some code for credit history and employment, personal status, and so on. There is a lookup table that resolve the code. Something that we can do, for example, is immediately have a look into duration of month, and you see on the right hand side here, there is a distribution. So typically, the majority of people apply for this length of duration in months, which is this one is probably around is 2 years. No, is say 24 here. The scale obviously is a little bit not normalized, but this is the 2 years application. And then there is also amount here. And then you see there is amount here, and then it goes with different amounts. So the smaller amounts are more popular. See the frequency of over 400 than the larger amounts. And then you can wonder, is there a correlation between duration and amounts? And what you can do is that you can compare. No? So you take the amount in here, and then you correlate, you compare to the duration, and you can see this interesting graph how it is scattered. And basically on the X, on the horizontal axis, you have the credit amount, so starting from 0 and growing. And then on the Y, on the vertical axis, you have the duration in month. So as you would expect, lower amount are typically repaid in a shorter duration, right? So if I borrow $2,000, I'll typically repay between 10 to 20 months, for example. But if I borrow something higher, like 100,000, then it'll probably take 5 years or even more to repay. So this is an indication of distribution, which is basically what machine learning does for you. And if this distribution changes over time, the machine learning algorithm will learn automatically by itself. And at the end, I am using 2 different training here. One is the 2-class boosted decision, and the other one is the 2-class support vector. Now, why these 2? Completely arbitrary, to be honest. I'll be very frank with you. And this is because classification has so many different types of algorithms that are pre-cooked and ready to use. Now, what is classification? Classification is a scoring mechanism for identifying a likelihood, a probability that something belongs to a class. So is a good repair or a bad repair. So high risk or low risk from a credit perspective. Anomaly detection we have already touched before. Clustering is identifying a cluster, if an element is part of a cluster or not, so it has the same attribute of other elements. And regression is an estimation of quantity. How many? For example, what the temperature like tomorrow. Is an estimate of a number. But in this case, because we are scoring a likelihood of a person being a bad or a good repair, so having a lower or higher credit risk, I'm going for a classification. And because I'm not a data scientist, I don't know upfront which one is going to perform the best considering this data. I'll be honest with you, not many data scientists may even know whether they want to use a forest or a jungle or a decision tree. So the best way to do this is to try. There is nothing wrong in trying. So you just add different training model. And then you see, okay, let me see how this works. This is not what I want to show you. This one. Now, this one is not going to be easy to read, but as you can see on the left-hand side, there are different branches in this decision tree that have been built. What happens basically, now this one is very, very hard to read, but basically is saying that, yeah, it is not going to work well. Let me try to zoom a bit. Okay, it's impossible to read, but anyway, it's a age, credit amount, purpose, credit history, job, age, employment, and so on. So all these bubbles here are a decision point. And if the data being analyzed is less or more than a value that the machine learning algorithm identifies out of itself, then it will fall into a decision branch. And this decision branch is low risk, high risk, low risk, high risk, until it arrives at the end and identify what is the final output, which is the score. Now, because I'm using two training mechanism, I want to compare them with an evaluation. And the evaluation will basically identify the performance, the accuracy, the precision, the true positive and the false negative, and compare them between the score dataset on the left-hand side and the score dataset to compare. Now, in this case, they are very, very similar. So you can see the two curves nearly overlap. So there is no major difference. You can see also the numbers here of accuracy and precision. They are very, very close to each other. Actually, the accuracy is exactly the same. So this means that either algorithm is fine, but you may have some other algorithm that don't perform well. In this case, you just remove it, and it doesn't mean that the algorithm is wrong. It means that this algorithm for this data set is simply not the most appropriate to use, and this is why you do different evaluation. Okay, all right. Now let's focus on the next topic, which is the aspect of confidentiality. So everything that we have seen so far runs into a machine learning algorithm that is working with extremely confidential data. This data is PII, personal identifiable information, because if you combine together employment status, age, country where you live, it's very likely that you are able to identify a person even if there is no name, email address, phone number. In doing this, we want to make sure that data being used by several parties, several institutes, several banks, is treated in the extreme confidential way, especially when you are aggregating different data sources from different institutes. Now, in the case of the German dataset, this is one dataset only, and it's also open source, has been anonymized, so there's no problem. But if you're working with real data that is aggregated by different data sources, then you will end up with a risk that you are exposing confidential data to unauthorized parties. Here is where confidential computing enters in action. This is not about protecting data at rest or in transit. This has been around for years and years already. Nothing new. SQL Server can encrypt data at rest. Nothing new under the sky here. HTTPS protect data in transit. Again, it's been around for years and years. Confidential computing is protecting data when it is in memory, when it is being used. Think for a moment. Your data is in the database or wherever it is stored, and it is encrypted. safe and secure in there. Then you take it and you load it in memory for being used, for being processed. In that moment, it's running in a memory space inside some server, some virtual machine, very likely. Well, that memory space can be seen, can be accessed by an hacker, by the administrator of that virtual machine. They can take a memory dump and they can totally see all the data in clear. It's just in memory, even it is running in the server. So just because it is running inside a server, it doesn't mean that it's secure at all. This is what confidential computing does. It protects data to run inside an isolated region of a memory. Completely isolated, that not even the operating system can see it. Not even the hypervisor where the potential virtual machine is running. And this is done, this encryption, this isolation is done at hardware level with special CPUs that have an extension, some commands that protect, that isolate this memory space by any party, any application that is not authorized to access this region of memory. You often will hear the name Enclave to identify this isolated region of memory inside a virtual machine where your data and your code is running. Being a memory space, you're not only using it for allocating data, but also to run application. So it's like you have your virtual machine, but inside your virtual machine you have a little black box, and inside that black box no one can access it, and you run your data and your code. If you try to take a memory dump, you see nothing. This is a WinDebug, is a screenshot of a WinDebug application trying to look into an enclave that is running an application, a SQL Server application in this case. And I don't even see scrambled data because it's not encrypted data. The memory space doesn't exist. It's not addressable because the CPU doesn't recognize WinDebug as an authorized application to be able to interact with this enclave. So this memory space is really like a black box. Now, speaking of SQL Server has also this capability, which is called secure enclaves. And basically, SQL Server can run inside a secure enclave and encrypt data at rest and in memory. Now, this is a table, an employee table that contains SSN, social security number, and salary. And these two columns are encrypted, only these two columns, not the entire table, not the entire database, only these two columns. But this is encryption at rest, nothing new here. Now I have a web app, ASP.NET MVC, you will probably recognize the template. And this app displays some confidential data on screen. Now, where's the problem here? The problem here is that I have a salary range as a filter and a search by SSN as a filter. So it means that I am building a SQL query that contains potentially sensitive data. And this SQL query is sent back to SQL engine. A SQL profiler, a man-in-the-middle attack, using a SQL profiler, can see this data, even if it is encrypted at rest, because it is in the SQL query. But with confidential computing, by running SQL inside the enclave, you see that the search pattern is completely encrypted. So not only data is encrypted at rest, but also the parameters in my select query, so in the where conditions, are encrypted And this is done automatically by the enclave. There is no software encryption here. Data is never encrypted and decrypted. There are no keys for encryption. It's all done at hardware level automatically by a SQL Server running inside the enclave. So a very typical use case for this enclave-based protection is a multi-party machine learning. What does it mean? It means that I can create trust between different parties, so let's say different banks, to share their data and still maintain the confidentiality. How does it work? Well, I install my machine learning application inside the enclave. And the enclave is a memory space that is completely isolated from the rest of the world outside. And only entities that have a key, and it's not just an encryption key. I said that there is no software encryption here. There is no asymmetric encryption. There is no RSA or triple DES, AES, whatever stuff you will use for encryption. This is a key that is issued by an independent attestation service that authorize bank 1, bank 2, bank 3 to submit, to post, to upload their data to the enclave. And that's it. That's all they can do. They cannot access the data once inside the enclave. Then the same attestation service is verifying the code, the machine learning code that is installed inside the enclave, and signing the code for execution inside the enclave. So the machine learning code can access data that is uploaded by the different banks to run inside the enclave. So none of the banks can access dataset shared by the other ones. Is completely isolated, running inside the enclave. Only the machine learning algorithm can access. So once it is inside the enclave, the machine learning application will combine all the different datasets, execute the training process, the scoring process, all inside the enclave, and then expose this as an API. But it's not exposing the entire dataset. It's exposing only the score, right? So we have seen this before. The score, the probability. So in this way, you are able to aggregate different datasets, increase the accuracy of prediction of your machine learning. The more the data you have in your dataset, the better, and provide a better service at the end without compromising on confidentiality of your data. Now, there is an extension to this model. This model is very centralized. All the banks have to take their data and trust the enclave and share it with the machine learning trust the machine learning service running inside the enclave. And because this protection is done at hardware level with an independent attestation service, I tend to say that this model can be trusted to a point that even the cloud provider cannot access the enclave because the cloud provider doesn't have the attestation. So assuming that this machine learning runs in Azure, even the Microsoft administrator of that virtual machine where that machine learning service is running cannot access the data. So banks can trust this model even if they don't trust the cloud provider. Now, there is an aspect though. There is an aspect that some of these banks or governments are very conservative. You know that, right? They don't feel confident in sharing their data outside. Hence, this centralized model can be extended with a concept called federated learning or federated machine learning, which is basically the centralized model where all the different data sets are aggregated into a centralized training infrastructure, which is the one that you have seen in the previous slide, which is confidential, running inside the slide, no problem at all. And then it produces one model. And that's great. That's fantastic. And it's still confidential. Well, no problem at all. But you need to win the resistance of some institutes to share their data, even with all the guarantees that we have said before. So Federated Learning, FL, allows to share the train model without sharing the dataset. So training happens still locally. There is local training. Each institute, you see institution A, B, and C, they do training locally on premises. So they don't share the data. Then they share the train model to a service called an aggregator that puts all together the different train models, and then this global model is used for the scoring part. Now, there are still some concerns on security and privacy, because potential attackers can compromise the global model, can compromise, can do a sort of reverse engineering on the train model and go back to the data that has been used for training. So we want to mitigate again this training model to be shared in confidentiality. And this is done again using confidential computing. So confidential computing can be used, as we have seen before, for executing machine learning training, but can be used also for sharing only trained model that have been pre-trained locally, but you still want to protect, you want to stop attackers from using that model without being authorized. Now, at Microsoft, we have a service that is called Onyx Inference Server, which supports exactly this mechanism of sharing inference data, so trained model, in confidentiality. Now, I'm not going to go too much into the technical details unless you ask me to, but this is a typical architecture design where on the left-hand side, you have your on-premise environment where you're running some Python code that is very likely in some servers, in some containers, and is running on an SGX enclave. SGX is an Intel technology that stands for Software Guard Extensions, which use hardware encryption to protect the enclave. And remember, the enclave is that memory space where your application runs. Using some frameworks, there are a few open source frameworks, you can build your Python application or your other programming language that you want to use for your machine learning service and interact, communicate with the enclave using an attestation service that authorizes the communication with the enclave itself. At that point, once your model is ready, you share it with the FL, with the Federated Learning Trusted Aggregator. The aggregator puts all together the different trained model into a global model that can be used and again shared in confidentiality in the cloud using confidential storage and key management, which with all the keys stored in an HSM, which is a hardware secure manage module, which basically means that also the keys are running inside an enclave. And that's convenient because you don't want to expose any untrusted component to the outside. Is on-prem to the cloud, end-to-end encryption, end-to-end protection of your data. All right, so this may go a little bit more complex than what probably should be for this audience and for this session, but I'm happy obviously to progress this conversation. Reach out to me, and we can go as much in detail as you want. In the meanwhile, or until then, to get started, a few pointers. Azure Confidential Computing is a product or a collection of products in Azure. It's not a new service. It's an enhancement to virtual machines, containers, SQL. So all the traditional services that you already know, that you already use, very likely, but with the SGX extensions, so with the hardware protection. Then Intel itself has released an open source framework for federated learning. OpenFL is on GitHub, and the Onyx server running inside the Enclave is also open source project by Microsoft. So you see there is a lot of open source in here, which is great. If you want to get in touch, there is a request form. You have the URL here on screen. I'll share the slide, obviously, with this community. So just fill in your request and you will get in touch directly with me. Or just feel free to reach out on the social channels. You know what? I'm going to be nice to you today. So let me do this. 1 second. Let me do one more thing. Hold on. Here we go. Yes, so reach out even via email directly if you want to get deeper into the specific use cases. It doesn't have to be necessarily financial. I picked 2 financial use cases today, but there are a lot of other applications that are using confidential computing. Do you know who is using confidential computing very broadly? The Signal Messenger app. They are protecting the social graph. They are not sharing with anybody the contact list. So not only they're not able to share because they don't have access, but even Signal itself cannot access the contact list. So they can't be used for targeting for ads. It cannot be sold, it cannot be shared with anybody. So it is nothing to do with financial, nothing to do with machine learning, but is yet another way of protecting your data from the cloud provider itself, from the administrator of the virtual machine, and from anybody, any party who is not authorized to access your data. So using hardware encryption and the protection of your data and code to run inside the Enclave. So thank you very much. Hope you found this combination of machine learning and confidentiality useful. And if you have any questions, please ask.
Thanks a lot, Steph. It was really interesting. I mean, I guess it's a huge step. All the concern that we've been hearing is how we can protect our data, how we can ensure that if we give our data to the cloud provider, it's not going to be stolen, and if it's safe, and we are making sure that we are giving that guarantee. I guess having that confidential computing feature, it's going to be a big step, at least to give people confidence that their data is safe. I have a question on that one. For the FL Federated Learning, are they still using Enclave and for the encryption, or because you mentioned that the data won't be shared or disclosed anywhere, it's only the algorithm. So where that encryption is happening?
So when locally, when you're running your training on premises, you may or may not use confidential computing. It doesn't really matter because it's your own environment. So the protection of data when doing the training of the model is up to the institution. But as soon as you want to share your trained model, at that point, the Enclave model, which provides access only to the authorized parties, will give you the protection. So technically, if you want to have end-to-end encryption, so from on-prem to the cloud, you will run everything, training and sharing of the model inside the enclave. But strictly speaking, is the sharing that is the critical part of it. And the training in the context of federated learning can happen also outside of the enclave.
Interesting. Thanks for sharing those links at the end, because I'm personally gonna look into it. David, I'm just gonna ask you if you have any question from our audience.
Hey everybody, what an amazing presentation. I'm happy that I'm using the Signal app as well. But I'm using...
So I can see a few
WhatsApp
questions.
as well.
Yeah. I can see a few
so
yeah,
so let me pick up one that I got in a different channel. So I know that you are a huge advocate as well of blockchain. Is there any use case for blockchain to be implemented as part of this protection?
There are. I mentioned Signal before as an app. Signal has done an agreement with the mobile coin for cryptocurrency payment from the app itself, and they're using confidential computing to protect the parties involved in the transaction and the transaction itself. We have seen also other customers using a blockchain digital ledger for creating audit trail, so a transaction log that is completely confidential, because that transaction log contains also confidential data. So anytime you have a data that is confidential, PII, that you don't want to share with anybody else, the only way to protect is to make sure that it runs inside this black box that we call enclave. In this way, only the parties that are authorized to access this confidential database or confidential ledger, that is a blockchain ledger, can access this data itself.
It's really cool, actually, to see how everything is coming together as well.
That's right.
Yeah, another question is, let me read this one. Okay, what are your thoughts on restrictions? Because it seems that technology is evolving faster than governments applying new rules or restrictions.
That's a very broad question, right?
Yeah.
Look, from a regulation perspective, some of the challenges that this technology brings, the confidential computing, are around subpoena initiatives, for example, which means when the government requires access to data. And in good or in bad, this is not possible. So that means that even if there is a regulation by the government to force you as a company to disclose this data, the problem is that you can't, because it runs inside the enclave. So the only way, obviously, is to create an attestation also for the entity of the government that will have access. But the attestation is independent, so it is not controlled by the company itself. For example, Intel has an attestation service that verifies that applications are authorized to run inside a specific enclave. Microsoft, as an independent party, has another attestation service that is actually technology agnostic, so it doesn't only work with the Intel SGX extension that I mentioned, but it can leverage other technology for confidential computing. So it means that if there is a bank that is protecting data, I'm saying a bank, but can be any company, and then you have a forensic investigation, and you are forced to reveal your data that is stored inside the app, inside the enclave. Well, that company cannot do anything. The the government, the police, whoever it is, has to reach out to the attestation owner and ask for access to the enclave. So there are multiple parties that are involved into this. It's an additional level of protection. Look, there is never guarantee of 100% protection, but we are reducing with this technology the attack surface. So then we have this memory space that is isolated, and that at the end it can be compromised, or it can be accessed, but it is much harder than using normal encryption.
That makes sense. So at least it has been in place for years, I imagine. So okay, Anisi, maybe this one is an easier question. I'll bring a JK to the stream. Hey JK, so because you asked this one, so go for it.
Yeah, so I have a question regarding AutoML. So you use the Azure Machine Learning Builder, which is really awesome. And you mentioned that we don't know which of these classifiers might be the best one. Could you just inject AutoML just for specific net scenario in that builder?
You can, yeah, you totally can. Look, I didn't want to make the story too complex, but AutoML is a way to identify the best performer algorithm, and it's definitely a way to optimize the machine learning algorithm that you are building, starting from analyzing the data itself. Yes, you're absolutely right. AutoML will definitely help in that case. Yep.
Awesome. And there might be some .NET developers that like to use EF Core, and being able to secure the database is really awesome. Do you know if it's possible to use Enclave and securing the database via EF Core?
There is support for .NET Core. I haven't tried with EF itself, but in general for the .NET Core up to the 3.1 version, we have support. The only thing, though, to consider is that when you communicate with the enclave, your application needs to have a communication with the CPU, and to obtain the attestation that I mentioned a few times. That is done by communicating with the CPU. And for communicating with the CPU, you need to go at lower level. This is done at C or C++. So if you're writing a C or C++ code, you can go directly with the Intel SGX and talk to the CPU. If you are using a higher level programming language like .NET, Java, Python, you need to go through other frameworks, which are all open source, but these frameworks create a sort of a wrapper that communicates a lower level with the CPU, but then you still use your high level programming language. Again, probably the story would be too long to say in one session only, but if there is an interest to get deeper into this, reach out to me and we can definitely follow up.
Awesome. And one last question for anyone who would like to try out what you've shown, or maybe not necessarily this particular case, but just being able to go to Azure ML and play around. Do you have some good data sets that we can start off and play around?
It's a bit tricky though. So that German dataset that I use for this credit risk prediction is open source. So it was in the slide, the URL. So as soon as I share the slide, everybody can take it from there. Any other dataset, there are some, but obviously, they've been artificially generated. Instead, this German dataset is real transactions, anonymized obviously, but real transactions in a specific amount of time that have been sort of collected together, and can be used for generating all these experiments.
Yeah, I found that one of the hardest thing for when you present and trying to get people on machine learning is giving them nice data sets to play around. So share us the URL and we'll include it to YouTube so people can try it out.
Perfect, will do.
All right, that's all questions from my side.
Thanks, JJ and David and our audience. Thanks, Steph, for showing your support to the community always. So thanks for sharing your information. I guess there will be lots of follow-up questions later on, and there will be lots of people reaching out. Thanks for joining us tonight. Hope you enjoy your rest of the afternoon, not afternoon, evening. All righty, let's carry on with the... Thank you. So Stefano's details are on slides, and we'll put it on the channel as well, so you can reach out to him, follow him, and he always opens to answer your questions. Then again, thanks for your support, Stefano. Alrighty, let's carry on with the presentation. A little bit of notes. Our next event will happen in 20th of May. Our guest and topic is to be confirmed and announced. So as soon as it's confirmed, I will share. Our team will share that through our channel. Follow us in our YouTube and also in our LinkedIn group. We'll be sharing different content regarding to our community as well as different topics that we have. In our YouTube channel, you can see our previous sessions. So if you're interested, there are different topics that we're covering, all AI related. But if you're interested, subscribe to our channel. You can see our previous videos. This one was live. It will be uploaded over there, so you can watch it later on as well. Just to reemphasize, if you're keen to speak and have an interesting topic to share, you can submit your session through our GitHub link, and we can take it from there. We are always looking for speakers, so if you are thinking to get into the public speaking, this is the best place to start. And there are lots of support that you can receive from the community. So here's the link. If you're interested, please jump in and submit your session. As I mentioned, subscribe to our channel, Global AI Community channel. Aside from our channel, there are lots of other contents and other communities that are providing their contents over there. So you can find lots of different topics regarding to the AI and ML, and the sky is the limit. So you follow and subscribe to our channel and enjoy the sessions and content over there. We are always looking for feedback. So please, it's just 3 questionnaire, submit your feedbacks. If you have a way, we are trying to improve our session and make it more interactive, as I mentioned earlier. So if you have an idea, we are happy to try it out. So similar to our games, if you are thinking that there is a way to provide sessions or even the live sessions to you, just share that idea with you and we can get in touch and we can talk a little bit more to see how we can iterate and make it more interactive so we all can enjoy. I guess that's it. Thanks a lot for joining us. All the links and the slide will be shared later. That's it. Enjoy your night. Have a good night, guys. See you next time.